Alright, so let's continue on doing the incremental rate of return, and let us look at a problem where we have machine X and machine Y for it. And we have initial cost for machine X is $200, and for machine Y it's $700. We have an annual benefit of $95 and $120. We have a salvage value of $50 and $150, and we have a life, and the life is 6 and 12. And this project is going to actually go for 12 years. So from our analysis that we've done before, if we're going to look at this and we're going to use the net present worth, that means we are going to have to acquire two of these machine X's. So we're going to replace machine X after 6 years with an identical machine X. So if we do this out, going from 0 all the way down to 12, we find out, first of all, let's do this. Since we're doing incremental, let us look and put them in order. Which one we're going to subtract from which. So we know we had always look at the largest initial cost, and the largest initial cost is $700. So we're going to put machine Y first, and we're going to subtract machine X from it to get our incremental. Okay. So we have a minus $700, and we have the $200. Then we have for machine Y, it actually has a life of 12 years, so it will use all the way up, and we will actually be an annual benefit of $120. And at year 12, we have $120, but also we have salvage value, which gives us a total of $270 we have up here. So we have the annual benefit plus the salvage value at year 12 that we actually have. So turning our attention to machine X, we have, in every year, we have 95. But when we get to year 6, we actually have the 95 plus the salvage value, but we also have to purchase a new machine in this case. So we have the $95, which is the annual benefit. We have the salvage value that we get from the turning the used machine in, but we do have to do an outlay of $200 for that one, which gives us a minus $55 here. For the remaining part, we then have the $95. And then again, when we get to the very end of its life, we have the $95 plus the salvage value, which comes out to be $145. So from this one, we do the incremental, where we're just taking Y minus X, and what we have is we have a minus 500, we have a 25, and then we have a 175, which means the 120 minus a minus 55 turns it to a plus, so it's 175. And we have the 270 minus the 145, which comes out to be 125. So we have our cash flow that we need to work with. We can do the net present worth. We set that equal to 0. We can find it's a minus 500 plus 25. We're going to find a P given an A at some kind of I for 12 years. So notice we just assume 25 throughout the entire thing. And then if we've done that, we leave 150 here that we need to account for. So we're going to find that P given an F, and then we're going to do it for I for 6 years. And here we have $100 that's left at the end. And that goes for 12. And so what we find out that the incremental rate of return is equivalent to 1.3%. And if we had our MAR, and our MAR was equal to 10%, that means that this is not greater than that. So we would not choose the higher, but we'd choose the lower. So in this case, we would choose machine X for it. So in this case, if we had an answer on a test, something like that, you would actually bracket or box the incremental rate of return that you calculated and also the decision that you actually made on which one to do. All right.